I work in the chemistry department. For my teaching, I teach undergraduate students general chemistry, physical chemistry. At the graduate level, I teach them thermodynamics, spectroscopy, surface science, nanomaterials. This is mostly motivated by the nature. I basically working on how to convert the sunlight into the useful chemicals.
In doing that, it can be combined with other catalysts and can be used hopefully downstream to make some process improvements to some industrial processes like reducing carbon dioxide to methane and also nitrogen to ammonia.
But if we break it down, we see there are two major steps. The first step is oxidize water. Okay, so we need to oxidize water one time. Basically the photosynthesis type 1 catalyst is do the water oxidation. This actually creates the most important chemicals there called protons. And then the protons work with the CO2 and then convert, basically reduce CO2 for the nature actually as plant do the sugar. In our lab, we can produce carbon monoxide, we can produce methane, we can produce methanol, or even longer chain carbon species that will be stored and sent to the manufacturers to do a lot of the, for example, plastic.
The real impact is that it can reduce the cost of some really substantial industrial processes that would save money in the long run.
Obviously, we target at this moment, definitely if you can convert carbon dioxide, we deal with this global warming, we deal with this climate change. But at the same time, we use the sunlight, the solar energy, it's basically free, and convert the things we don't want, carbon dioxide, into the things we need in our daily life.
I think the potential impact on the size of the processes, the scales of the processes, could have a huge economic impact. Dr. Wei, I'm excited we picked your invention, the efficient photocatalyst for water oxidation, as invention of the year. We're very excited about the potential economic impact in the future, and congratulations.
I would first thank my students, my postdocs. This is obviously teamwork. My collaborators. The science I'm doing is a multidisciplinary research. So I have collaborations with material scientists like Dr. Jiangeng Xue from Material Science Engineering. I have a computational collaborations. I have national lab collaborations. Without my students, my postdoc, without these collaborators, I don't think this thing happened. All the service department from chemistry, all the service department from university level. As we talk, I thank the OTL, the office, especially Danny, who has a background with the chemistry, right, to make this. We already in tech for the past 5-6 years. He was very greatly helpful with all the office, his office people. Finally, thank the University of Florida again, offer the opportunity, offer the platform, and go Gators.